Here's the definition of convex polygon. A convex polygon is a polygon in which the measure of each interior angle is less than 180 degrees. And here are some examples. Two have 3 sides, of course they're triangles. One has 4 sides. One has 5 sides, a pentagon. And one has 6 sides, a hexagon. And here are 3 examples of concave polygons. You can see that all of the interior angles are not less than 180 degrees in these 3 examples. While these 3 examples are all polygons, this study of geometry will primarily concern itself with convex polygons. And here's another definition, diagonal. A diagonal of a polygon is any segment that connects 2 non-consecutive, also known as non-adjacent vertices of the polygon. And let's take a look at our examples. The 2 triangles have no vertices which are non-consecutive or non-adjacent, so triangles have no diagonals. But let's look at the 4-sided figure, also known as a quadrilateral. And many of you may know that specifically that one looks like something called a trapezoid. But right now let's just look at the diagonals. There's 1 and there's 2. A 4-sided polygon has 2 diagonals. And now let's go to the pentagon. 1, 2, 3, 4, and 5 diagonals in a pentagon. And now the hexagon. 1, 2, 3, 4, 5, 6, 7, 8, and 9 diagonals in the hexagon. There are formulas to help determine how many diagonals a polygon has based on its number of sides. But this lesson is primarily about 4-sided polygons known as quadrilaterals. A quadrilateral is a polygon with 4 sides. And here are some examples. You may already know some special names for some of these, and the last one put up, of course, looks to be a square. But let's start with one special category, the parallelogram. A quadrilateral in which both sides of opposite sides are parallel. And here's an example. And now the rectangle. A rectangle is a parallelogram in which all 4 angles are congruent. So notice, this rectangle is already a parallelogram, and the 4 angles are all congruent, and they appear to be right angles, which of course they are. And another name for a rectangle is equiangular parallelogram. You could also call it equiangular quadrilateral. Here's the rhombus, a parallelogram in which all 4 sides are congruent. The angles don't have to be the same, and they're not in these 2 examples. A rhombus can also be called an equilateral parallelogram or an equilateral quadrilateral. And that brings us to the square, a parallelogram in which all 4 sides and all 4 angles are congruent. And a square, of course, is both a rectangle and a rhombus and a parallelogram and a quadrilateral. A square can be called a regular parallelogram. Could also be called a regular quadrilateral. We already know that in a triangle, if it's equilateral, it has to be equiangular and vice versa. But for other polygons, the polygon can be equiangular but not equilateral, can be equilateral but not equiangular. But if it's both, the polygon is called a regular polygon. And that brings us to the trapezoid. Trapezoid is a quadrilateral with exactly 1 pair of parallel sides, and here's an example. But wait, there's more. Trapezoid is one of the few terms in mathematics that not every mathematician agrees on the definition. Another definition of trapezoid is a quadrilateral with at least 1 pair of parallel sides. The 2 definitions are similar, but not the same. Under the top definition, parallelograms are not trapezoids, and trapezoids are not parallelograms. But on the definition on the bottom, where it has at least 1 pair of parallel sides, while all trapezoids are not parallelograms, all parallelograms are also trapezoids. And then if you use the top definition, we have the isosceles trapezoid. An isosceles trapezoid is a trapezoid in which the 2 sides that are not parallel are congruent. Those 2 sides are called the legs. And a right trapezoid. A right trapezoid is a trapezoid with 2 right angles. And here is an example. And here's one more quadrilateral, the kite. A quadrilateral with two distinct pairs of congruent adjacent sides. And for the second time in the same lesson, there's an alternate definition for a term. The alternate definition for kite states that a kite is a quadrilateral with two pairs of congruent adjacent sides. If we take the bottom definition, then rhombi and squares are also kites. If we take the top definition, then a kite is very distinct. It can't be a parallelogram, can't be a trapezoid. A kite is just another quadrilateral with some special characteristics. Well, here's the family tree of quadrilaterals if we use the top definitions for both trapezoid and kite. We start with quadrilateral, which means four-sided polygon, and then we have three distinct types. The parallelogram, which includes rectangle, rhombus, and square, and you can see at the bottom, the square is the merging or the intersection of rectangles and rhombi. If a parallelogram is both a rectangle and a rhombus, it is also a square. And then, separate from parallelograms are trapezoids. Trapezoids can be divided into isosceles trapezoids or right trapezoids. And of course, there are also trapezoids with no special characteristics other than one pair of parallel sides. There is no overlap between a right trapezoid and an isosceles trapezoid if you use our first definition of trapezoid. And finally, we have the kite. And again, a kite can't be a trapezoid or a parallelogram. What it has in common with the other polygons on this page is that a kite is another quadrilateral, meaning that a kite has four sides. In this lesson, we looked at four-sided polygons. They're called quadrilaterals. Some special types of quadrilaterals are parallelograms, rectangles, rhombi, squares, trapezoids, isosceles trapezoids, right trapezoids, and kites.